Hello, I'm Eric Snodgrass, and thank you for watching this Thursday night in-depth ag forecast brought to you by Nutrien Ag Solutions. Our first map tonight is the last 72 hours of total accumulated precipitation, and what this is largely capturing is kind of the prefrontal rain band that moved out of Texas into parts of the Midwest up toward the Great Lakes, and then the large front that swept through behind this, which has really dropped the temperatures considerably in a big section here of the eastern half of the country. And last night, as I was watching the radar, there were several severe storms that kind of erupted down here in the lower and mid-Mississippi River Valley. Several of these produced some pretty large hail. But as we were watching these go through, it was interesting to see the storms come across on the front that was right up here coming through Wisconsin. What I'm talking about is this. This is the storm reports map from yesterday. And looking at the unfiltered reports, we have 128 different events. A lot of the wind and hail damage was down here. Several of these storms were putting down 2-inch hail and larger. But it was this cluster right in through here in the southeastern corner of Wisconsin that really kind of caught my eye. So this morning I had a chance to go back and look at some of that radar data, and I want to show it to you. So let's go take a look. Okay, what I've got for you here is a split screen. On the right, I have your typical radar reflectivity image, and on the left, I've got a radial velocity image. So just as a quick reminder, on the radial velocity images, the red means that the wind is blowing the precipitation away from the radar and the green toward. So if the radar is here in the black dot, the green to red tells you the direction these are going. We could also just play it, and you can see the direction the storms are going. But this was a very narrow band of storms. My colleague Andrew Pritchard likes to call these, what does he say? It's a pencil-thin band of thunderless convection or something like that. But as you can see, it moved through this part of southeastern Wisconsin. And you saw that there were several reports of tornadoes. And if you go back through and look carefully, you'll notice that in several places along the leading edge of this line, like here and here, there's all these little indentations. And what I think happened, and I'm going to have to go back and read some of the content from the National Weather Service out of southern Wisconsin. I think we just had several places along the leading edge of this storm where we had such strong horizontal wind shear, we got weak, brief tornadoes to spin up. And apparently there were 8 of them along this line. So just kind of a neat thing to look at here in the velocity imagery when the reflectivity makes everything look just like a big long line of storms. So I just wanted to share that with you. Okay, so this is where things sit today. We've got a lot of cold air, very strong winds on the backside of this. These wind gusts today have been in the 30 to 60 mile an hour range. And what's going on here is this is all wrapping up into a broad upper level trough that's sitting here, and low pressure systems are kind of orbiting this. What's interesting is we have a little high pressure cell here, a little anticyclone that's in this part of Texas going in this direction. And this is Tropical Storm Carl, which is going to be heading down into parts of Central America and Mexico here. Now, when we were watching this today, there was risk in this whole area of field fires, wildfires, because of the strong winds and what has been very dry conditions in parts of the plains. But I was looking today on satellite, and I didn't see a lot of smoke here just yet. That doesn't mean that more fire couldn't possibly erupt, but I didn't see that. What I was watching carefully, though, was a couple things. Like, for example, look right down here on the sea breeze coming off the southeast coast of Texas. Really fascinating to see the storms pop there. I'm also watching this. It doesn't look like much, but this is actually the cloud cover coming around. See it right here? Coming around the cutoff low that's at the base of the high over low pattern, or the Rex block that's over the west. You can see, since we're speaking of the west, the smoke from the wildfires that are here in parts of the Cascade Mountains, which have been exceptionally dry throughout much of the last 45 days. But trapped inside of this deep cloud cover here, wrapped around the Great Lakes, we actually had some snow coming through the backside of this. And I was watching that too. So what we've got here are the service observations. This is all the weather station data. And we can see that some of the winds up into parts of Manitoba were gusting almost to 50 miles an hour. But the temperatures here, a lot of these low 30s with dew points in the upper 20s. And what I was looking for is this. See that double asterisk? That is the symbol we use for snow. And so you can actually see it in a few places. One right here in parts of North Dakota near Grand Forks. And then we had this right in central Minnesota, a few places showing up with some snowflakes. Now, bigger picture things that are going on here. We're blocked up right now, and the block is happening here. There's a large ridge in the west. There's high pressure to the south of it. There's a low pressure center south of that. So you get what's called a Rex block, or a high over low block. You then see the deeper trough that's sitting over the east, and blocks have to be around for at least 7 to 10 days, and we're now into this one, and we're likely going to see it persist for quite some time. So we're going to watch another cold front come slicing through here at the end of the weekend, delivering a lot more cold air, and that's going to send the frost line pretty far south into the southeast through the Tennessee Valley, while much of the west stays quite warm during this pattern. The number one thing I'm watching, though, is for momentum to start to build in the flow of the atmosphere right here in the Bering Sea, in the Chukchi Sea, over parts of Russia and Alaska. It would take something coming through here to dive down into this ridge to just kick it out of the way, flatten it out, and get rid of it. So, in the near term, that's not happening. So if we just start this animation from our high-res NAM model late this afternoon here, about 6 o'clock on Thursday, we see the first system exiting, so the heavier rains moving through parts of New England, the snow showers in the overnight hours tonight coming through parts of Minnesota, eventually into northern Wisconsin and the UP of Michigan. There is a weak frontal band that is going to travel through parts of southern Wisconsin into Illinois by tomorrow night, but that's going to move quickly into Michigan and Indiana by early Saturday morning. And then what we're going to watch after that is the next cold front arriving on Saturday, diving down into the midsection of the country. I'll give you those temperatures in just a few moments. What was also going on during that time, take a look down here. But just go back. Do you see here right at the end of the animation on Saturday into Sunday, you get a sense of some counterclockwise flow. And what we've got here is an upper level low that's going to move across Arizona, New Mexico, and Texas, delivering some rainfall. That upper level low sits here. But the bigger features are the Rex block, the deep trough that's off to the east, and what's happening up here. Now, we've been watching this all week. There has been some kind of longer-term outlooks I've given that suggested that this ridge wasn't going to last to the end of the month. And I keep getting hints of it breaking down, but through the weekend, this is now through Saturday into Sunday and Monday, we just see the reinforcement of that larger ridge in place. And the deeper trough that just dives here early next week, that's going to be the time period, Monday morning and Tuesday morning, that the coldest air sags pretty far to the south, hitting parts of the Tennessee Valley and the southeast. But this was what I was keeping an eye out on. Given the changes in the trade winds, the movement of the MJO right now into phase 6 and maybe even bordering on phase 7, we had to be on the lookout because of the teleconnection there for troughs here. And in the Bering Sea on next Wednesday is a deeper trough. And the models have been toying with the idea of letting that pull through Alaska, dive into the Gulf of Alaska, and really just hammer parts of the West Coast. Now, whenever we're teaching new students about how to forecast weather, they will learn very quickly for the United States that a jet stream pattern that dips over the west, runs over the Rockies, this is the type of pattern that can draw in moisture from the Gulf, sends low pressure systems. We call this lee cyclogenesis, lee for the lee side of the mountains, and the lows just tend to go like this. We have yet to see, okay, but let me be very clear, if this trough will indeed push through the mountainous west, or will it stay here out in the open ocean? That's going to be the key to try to figuring this out. You've been looking here at an operational model run. By the way, this is not a hurricane down here over Florida. What that was is that a piece of this trough gets sheared off to the south. Do you see it? And it's a cutoff piece of the jet stream that just sits and spins over Florida. So that's a lot of cloud cover and some cooler conditions down there. And again, we'll see that here in a few moments. So here's the supporting evidence for the pattern change happening at some point after the 21st or the 22nd. It's showing up in the Ensemble model runs. This is the European Ensemble. There's the trough we're discussing. And I can go over and show you the GFS Ensemble. Now, it is important to note that the GFS Ensemble, at the same time period, let's see here, this is next Sunday, not this coming, but next Sunday, is trying to keep that trough off the coast, whereas the European Ensemble is bringing it through. That would tell us that the European is going to be much wetter as a forecast model across the Northwest and likely send systems across the northern tier of the U.S., which of course will draw on that Gulf moisture. Now, I got a great question, and I thought we'd just address this. I had a good time talking with my colleagues, Matt Reardon and Andrew Pritchard, about it today. A lot of times folks don't know what I'm referring to when I talk about an ensemble. And so some of you do that are watching this, but for those of you who don't, this is for you. When we say ensemble, what we're referring to here is the fact that the European Center and NOAA will run their flagship models, the ECMWF and the GFS, multiple times with slightly different initial conditions. The point behind doing that is to generate several forecasts and see if those small perturbations in the initial conditions affect the overall outcome. So we're going to look at the outcome from the GFS ensemble, which right now is a 31-member total ensemble. The ECMWF has 51 members to it. Now, what you're looking at here, these lines represent the 5,520 meter height of the 500 millibar pressure surface. Now, if that is a little bit beyond what you understand about the atmosphere, what I'll tell you is this is mid-level flow. You can just follow the lines from west to east, and that's the way the direction the wind is going to go at this level. Now, these are ridges. There's a big ridge here, and this is the trough. Okay, what we're going to do here at the College of DuPage website, great website by the way, is we're going to see, as we move forward in time, how the ensemble members start to show spread. So I played it out there all the way to next Tuesday night. There's still a ridge here, and a ridge that kind of builds along the west coast, and there's the trough. Most of the ensemble members are following that same path, but did you see how they started to diverge? That's what happens when you introduce just a small amount of air, which could be plausible in the atmosphere due to initialization issues. Like we didn't capture a perfect picture of what was going on when we started the model. This is how we account for that. And what we have to do here is to see how long they stay together. So let me just take you all the way out there. I'm going to go right out here to, let's just go to day 10, right at this point. Now, it looks like a mess. In fact, did you notice what they call these? They're called spaghetti plots, and it looks like a plate of spaghetti that I gave my son. But what I'm noticing here is that we're still seeing a clustering of the blue lines here. None of them are racing up into a large ridge. They're all doing something like this. And that's an indication that the likelihood of breaking down the ridge that was here and delivering a trough along the west coast is higher than otherwise. And maybe that ridge starts to move across the country at that point. Now you start to see there is a tremendous amount of spread in this. So what I like to show, because it turns out when you average all of this, you get a better overall result. What I always like to show is the ensemble average. So what this map is it's the average of all 51 members of the European model at day 10, 240 hours. That's what the black lines are. And then the blue and the red represent the difference from the climatological normal. So what this is telling me is there are more ensemble members developing a deep trough centered over Washington State next Sunday morning, and the majority of them are producing that same forecast. That's it. That's what we've got. All right. Now, what does all that mean? Remember how we keep going on and on about the jet stream extending across the Pacific? At that same time, rather than breaking up into large ridges here, which it's been doing, we see that it starts off the Himalayas and completely traverses the North Pacific and finishes in Oregon, Washington, Northern California. And what we want to know is, will this happen? There's ensemble support, but there's a few other things that need to line up to make that occur, because the global wind system is all one interconnected feature. And all of those differences in the way the wind pattern flows from the North Pole to the South Pole ultimately affects where these fastest wind bands are. It's all driven by temperature too. So I'm going to show you another way by which we look at the ensemble support. And we're going to look at something called the PNA, the Pacific North American pattern. Now, you know we stress throughout the entire year the importance of watching the Pacific jet stream come into the western United States. When it ridges in the west, it's usually cold east. When there's a trough in the west, it's warm in the east. And a trough in the west and warm in the east also tends to produce a lot of active weather, especially severe weather in spring. Now, you've been looking at a graph of the PNA, the Pacific North American Oscillation, or the Pacific North American Pattern. When the values are positive, we tend to have big ridges over the west. And when the values are negative, we tend to have troughs. So using all 51 members of the European ensemble, and then producing a distribution of them with this box and whisker plot, we see that the vast majority of the ensembles, and then the control run, which is the blue line, favor that out there around the 22nd, 23rd of the month, there's going to be a big trough that dives into the west. Now, why is that going to be there? This is the support from elsewhere around the world. We've talked about these maps endlessly for the last several months. It's the trade wind map right across the Pacific. This is today, and this is going forward in time, almost to the end of October. You know that these blue-green lines represent strong trade winds from this direction, and the reds represent westerly wind bursts from the Indian Ocean. We can also say that if we draw a line right down the middle where they meet, that just tends to tell us where the rising motion is going to be, and therefore the position of the MJO. It's right now, if we just line it up over the next few days, it's almost in phase 6. And then you see the shift over moving toward phase 7. When there's a La Niña, because of the strength of these trade winds, it's very rare to move all the way back over to phase 8 and 1, or even return back over here to the Indian Ocean. It just tends to stay in this area. And that's why when we look out there at the forecast of it, the MJO did break out into phase 5, but it's gotten into phase 6, and it is not advertising motion like this. It's saying, I'm going to have to stick around this Western Pacific somewhere in this area because those trade winds are still very strong. Now, we can historically correlate this with weather patterns, and this is challenging because sometimes there's a lag in when this occurs and the resulting jet stream pattern changes, and sometimes it seems to be almost direct. But we do know this. If it is November, which is what we're heading toward, and the MJO stays in phase 6, you tend to get more of those troughs diving out of the Bering Sea in Alaska into the Gulf of Alaska and ridging events in the midsection of the country. And when you look at this, you might be saying, wow, it's just going to be really warm in the midsection of the country and very unsettled in the west. Please understand you're looking at a static image. This whole pattern moves with time. So what I would tell you is to expect much more volatile weather. We've been very stagnant for the last 40 days. This is the pattern change we're trying to diagnose to see if it comes on and stays on. Now, what could crush the forecast? What could make this all very wrong? Firstly, if the MJO just comes crashing back into null space or pops back out into phase 5, that means the trade winds have completely regained their dominance, and that's going to retract the jet, force it to go back into a ridge over the west, and we'll go back into the pattern we've been seeing, which is very dry in the Midwest, very cold at times across parts of the eastern United States, and warm west. That's going to be the first thing. Also, if we get more blocking in the Atlantic side of it, that can slow things down as well. I haven't talked too much about the Atlantic because I think most of the pattern's being driven by the Pacific jet stream. Okay, so now you know what I've been watching. Let's show you how the models respond. Now, we've already seen through Thursday, today, into Friday and Saturday. Let's park this out here where the other model left off. The next event we're going to be keeping an eye on is that cutoff low moving on Saturday into Sunday through Arizona into New Mexico. And it's going to link up with a broader front that's going to stretch from Texas right through the Mid-South and come over here to the Appalachian Mountains. That's the second cold front that's going to dive through. And when I say dive, I mean it's really going to push cold air south. This is by Monday evening. Look at the dominance of the high pressure on the backside of this. That will extend that front all the way down to the Gulf Coast, and it'll kind of curl around right here into parts of New Mexico through southern Texas. That pushes all the way out into the Gulf of Mexico. That front will extend more than likely clear down through Florida. And this is what we expect things to look like next Tuesday night. Now, there's going to be a lot of cold air coming in with this, and you can see the blue representing the snow. As we play it forward, remember, the pattern for the next week, maybe 8-9 days, is still dominated by those troughs. Where our attention is going to go is here. You'll see here that this is the 21st. If the trough begins to dive in, the European model suggests a major increase in precipitation across the west coast. And this could get all the way down to the Sierra Nevada mountains. It could bring snow to the Cascades, and it could really set up a very active pattern in the midsection of the country with the development of a Lee cyclone. Now, the point is to show you that if there's high pressure extending along this area, the wind will kind of flow like this. And that's drawing moisture out of the Gulf, which could set us up for that, the end of that third week of the month with the chance for a pretty potent system. But I am out here at the end of a single model run. That's why I showed you the ensembles first, to let you know there's support for this. So what are we going to get in terms of total accumulated precipitation? This plays through the weekend, and you can see that through the weekend, this is Saturday, Sunday, Monday, that's when the rain sets up on the front. The flow still goes around the upper level low, and we bring the moisture out from the cutoff low through Arizona, New Mexico, and Texas. But if you're in the plains and parts of the Midwest, even parts of the Southeast, there's not much to be seen. And of course, it's dry across the West Coast where the Rex block is. That all changes the following weekend. Can you see it there? Saturday into Sunday, that's when the trough dives in. So we're going to have plenty to talk about here over the next 7 days as we wait to see if the models continue to point toward the development of this. Given that we've watched it for 4 or 5 days, I have a bit more trust in it. And remember, it's shown up in the ensembles, and the models are reflecting that. This is the week 2 precipitation pattern, and you can now see the increased chances of it being wetter across the western United States. If that occurs, we'll see more frequent systems in the midsection of the country, and this region won't be dry. By the way, there's also analog support from this. Out of St. Louis University, they run an analog using the GFS Ensemble. And what you've got is the next week, the next 10 days, and then down here, the temperature pattern going out there into that fully into that second week. And you can see the cooler conditions coming in while the warmth begins to return here under the ridge. The other thing that's important to see about this is that at that time, it historically has been able to pull more moisture out of the Gulf back into this region. Now, we're trying to harvest a crop in here, but this is suggesting that we could be pulling some moisture into an area that has been very dry for a while. Even with the rain included that we've seen lately, there's still a large area in the central United States that's showing up exceptionally dry. And we're at the driest on record where the fires are currently burning in the Cascades here. But this could all change with that pattern adjustment. And why we talk about all of this and care about it is because I'm watching for these adjustments to take place, because ultimately I want to go through winter eliminating this. Our newest drought monitor today shows us a substantial portion of the United States still in drought. It's anchored in the west, where Central Valley of California, both the Sacramento Valley and the San Joaquin are having their driest year on record. There are parts of the Central Plains where we're trying to get a winter wheat crop established, and it's been extremely dry. And you can see this extends north-south right in the middle part of the country. How much of the country's in drought? If you ever go to the U.S. Drought Monitor, go to Time Series, and then you'll get this graphic. And if you just hover the mouse right here over the edge, the very edge, it'll tell you what the current drought area looks like. And according to the data here, we've got 81% of the country in some stage of drought, with a full third of the country in severe to exceptional drought. That's just one of the nice bits of this tool. Now, let's come back to the temperature side of this equation. You've got a look here at over the next 7 days where we expect to see frost. It's that second push of cold air that comes in through here. That's the one that's coming Monday, Tuesday, and Wednesday of next week that could send temperatures below 32 Fahrenheit into northern parts of Arkansas, clipping parts of northern Mississippi, Alabama, Georgia, and even getting into central parts of Virginia and North Carolina, maybe hitting Raleigh with a temperature getting pretty close to freezing. And that would be early. Their normal first frost dates are in early November. So if we look at those temperatures carefully, this was today's highs. This is tomorrow on Friday, getting into Saturday and Sunday. Now we're going to see the big push of cold air coming in Sunday into Monday. There you go. That's high temperatures on Monday and Tuesday. You've noticed that the west stays warm through this whole time period. That's where the Rex block is. That's where the ridge is. And we keep reinforcing this trough. This is how things shape up next Wednesday. How did the low temperatures shape up? Well, this is this morning. So let's now go to Friday morning. There you go. So we have our frost line right in through here for early Friday morning. This is now Saturday morning. Sunday morning's lows. Getting into Monday. Now watch the cold push on Tuesday. There it is. And then on Wednesday. So Monday, Tuesday, Wednesday next week is when we introduce that frost threat into this area. Now we're going to watch these temperatures evolve, and I'll put it in my morning reports. So don't expect this to be perfectly accurate 7 days in advance, but it's what we got our eye on. But as you know, that cold air, which for most of the next 7, 8, 9 days is going to be over the east, watch the changes occurring once we get past day 10. So now we're going to incorporate that model shift, the shift we're seeing in the model of the trough showing up in the west. And notice how it opens the central part of the United States up to some warmth and the moisture return, and things go colder in the west, which means we're going to be talking a whole lot more about snow coming really soon. Let's finish this up with a quick long-term discussion. Today's newest ECMWF forecast for almost the entire month of November is shown. And again, it's come up with a much more rigorous pattern. In other words, more frequent systems coming into the west and moving across the central United States. In other words, it's lost the big blocky features and is favoring more troughs of low pressure off the west. I won't even bother showing you a temperature map for this time period because it'll be useless. The fluctuations will be so large that to just think that it's going to get stuck in one configuration, I don't think it's going to happen. So bigger picture from there is what's going on with La Niña. And as you can see, we have a large area where the trade winds continue to cause upwelling of cold water here. And what I want to talk about is as we go into November, If we just correlate the colder water in the central equatorial Pacific with historic weather, we do find a much more active and wetter pattern for the Pacific Northwest extending through the north interior of the United States. The drier conditions tend to be farther to the south, especially over the southeast. And one of the big reasons for this is the jet stream tends to do this with ridging over the southeast. And that's why we see the setup that we do with precipitation. And so, when we come back and look here at this map, that's why it has the shape it does. La Niña still is dominating this pattern. But I've been asking the question, how long does the La Niña last? And here we go. Some new data released from the Bureau of Meteorology out of Australia. They combine, again, their own forecasts with the Canadians, the Europeans, the Japanese, the French, the United States, and the British, and they get a mean. Now, what we've got here is from November into December, and then into January. You notice the ocean temperatures are pulling back toward neutral. By February, there's a big move, and the models are suggesting that by March, well, the people that are most aggressive on forecasting the return to INSO-neutral and then possibly seeing La Niña emerge are the Australians. And let me tell you something, they care about this more than most people around the world. So we need to watch that very carefully. That same forecast has also been echoed, this was just released yesterday, in the new forecast from Columbia University. The blue bars representing the probability of La Niña, the gray probability of neutral, and the red probability of El Nino. And we just see this transition happening, in the kind of the second part of winter. And if that occurs and La Niña backs off and we lose that strong trade wind signal, this one right here, you're going to see a lot of sub-seasonal factors take over, like the MJO, like the polar vortex, blocking in the North Atlantic and North Pacific, which means weather predictions going to decrease considerably in the longer term. Now, when I look out there, there's a couple things I'm paying attention to. I think that the CPC has got the best guidance on the early winter temperature profile. I think we will be colder across the northern tier and even across the east for much of winter this year, colder than normal. If there's warmth, it'll be over parts of the southwest and maybe down here along the Gulf Coast compared to normal. I also buy into the European models forecast for the winter, especially the January, February, March outlook. With the collapse of La Niña, we could get more of a subtropical component to the jet, which increases the moisture transport and better chances for more systems in parts of the Mid-South down to the south and southeast. It also brings in better moisture into California, which is something that's desperately needed. But right now, with the La Niña being so dominant, I was very surprised to see that the models really doubled down on the drought extent over the next 45 days in parts of Paraguay, southern Brazil, Uruguay, and Argentina. And you know, if you keep up with my morning reports, Argentina has been struggling with drought immensely. And this new forecast is unforgiving to that area. This is typical of a La Niña in spring to put more rain north and less rain south. And we'll get a new report late tomorrow on Friday at the planning progress in Mato Grosso. I don't expect it to be as fast as last year, but still ahead of the 5-year average. So we could be watching a pretty substantial issue brewing down here in Argentina, and I'll keep you up to date on that. Hey, I appreciate the extra attention and kind of let me do a little teaching today. I certainly enjoyed doing that. Hope you all have a good rest of your week and weekend, and we'll talk again soon. Thanks.